The next dimension in commercial fashion, bringing the fast fashion consumer and 3D garment design closer together. During my career as a menswear designer, I've worked with multiple retailers and brands at different market levels within the industry. All of the businesses I've worked with have two common issues: large quantities of unsold stock due to non-demand driven overproduction, and the strain overproduction and excessive product development is having on the garment supply chain and its workers. With retailers trying to remain in line with their fast fashion competitors' pricing architecture to continue offering affordable ranges, businesses are opting to purchase more garments to obtain lower cost prices. The more units a retailer buys, the less they have to pay per unit. However, the amount of garments that are being manufactured often exceed actual consumer demand. This is leaving retailers with growing amounts of dead stock and additional product development, which is increasing the fashion industry's negative environmental, economic, and social impact. 100 billion garments are produced globally each year, yet $450 billion worth of these are discarded into landfill. 30% of all garments produced are never sold, whilst a further 33% of all garments are disposed of in under a year due to low quality. 15 million European dead stock garments are sent to developing nations weekly. 40% of this product cannot be resold due to the low quality. Only 1% of textile waste is currently being reused or recycled, and in total there are 93 million metric tons of dead stock garments being sent to landfill each year. I believe I've spotted a gap in the market for a new e-commerce model that aims to sell 3D renderings of garments directly to the consumer in a pre-sale format pre-production. This will allow businesses to accurately predict product demand and only manufacture garments that have orders against them, leaving no unsold stock. Utilising direct-to-consumer 3D design will eliminate the need to create multiple garment prototypes, which will minimise development processes, leaving production lines open for more ethical manufacturing, working towards solving the social issues surrounding overseas garment supply chain workers. This will also open up more affordable in-season manufacturing, which could make the cost price of garments more affordable with no need to buy additional units. My proposed final MA outcome will be to create a business plan and functioning digital mock-up of how this platform will look and function for both the business and the consumer. However, when researching further into these ideas, I've found that there is limited literature and research around the fast fashion consumer's willingness to buy clothing from 3D renderings, which is a key part of my proposed innovation. I'm utilising the transdisciplinary practice module as an opportunity to further understand the consumer's willingness to engage with 3D design product and obtain feedback from the viewers of this installation to further inform the development of my e-commerce innovation. The main objective of this project is to further enhance the research surrounding consumer-facing 3D design and essentially discover if the fast fashion consumer would be willing to buy from 3D garment renderings. During my first semester, an imperative part of my research and one of my main aims was to find ways to establish a relationship between the fast fashion consumer and 3D garment design. This is not a brand new concept in the fashion industry, but it is limited to the luxury end of the market. With VR and AR tech being some of the tools used by luxury brands to communicate virtual garments to consumers, there lies limitations when it comes to bringing this immersive idea down to the lower end of the market to the cost-sensitive fast fashion sector. The cost of using this technology for the specific fast fashion market would be an impractical and likely unaffordable solution. Pictured left is an outcome from Research and Practice 1 in which I created a small-scale hologram. This is less interactive and immersive than anything achieved by VR technology, however the cost is considerably lower, and I believe scaling this idea up and refining the image and animation quality could provide consumers with a view of a garment that is so true to life that they would be willing to purchase without viewing physical items. I plan on working collaboratively with a number of professionals in digital 3D design and technology to create a more refined and elevated version of this idea, but most of all I want to gain a better understanding of the processes involved in this concept and identify any limitations that may inform the progression of my MA final e-commerce platform outcome. Meet the collaborators. I've taken on the role of project manager. My career history ranges from designing products for corporate e-commerce giants, independent brands and high street retailers, managing small teams to achieve collective goals within my skill set. My key roles within this project have been briefing the collaborators on all aspects of the project, designing a unique range of garments that fit within the aesthetics of my project for consistency, managing timelines and deadlines amongst my collaborators, and assembling the final outcomes and showcasing this project, as well as collating research findings post-presentation. The second collaborator is Tom Penn, who is currently the 3D concept creator and designer for Adidas. As an expert in his field, I've utilised Tom as an advisory and supervisory figure. His knowledge in the field of digital and 3D design has allowed me to assemble this team of creatives who offer skills that are outside the parameters of my own. His main roles within the project have been advising the best course of action to take to achieve specific goals. Tom has provided contacts of experts in 3D design and animation from his personal industry network. Tom has also played a key role in arranging critical path timings. As all of the professionals I've worked with on this project are working full-time in their sectors and are located in different parts of the world, managing timings is key. The third collaborator is digital pattern cutting and 3D design expert Catherine Reverin. Catherine has worked with high-end retailers creating virtual garment patterns to create minimal lay plan waste. This is now translated into a passion for zero-waste 3D garment design using Clo3D. Catherine's roles within this project have been to build and create digital patterns and 3D garment renderings with me based on the brief I have provided. She has offered advice on fabrication, lighting and rendering techniques to ensure we get the best visual and lifelike outcome. The fourth collaborator is Thomas Redden, a 3D animator and content creator who has worked with the likes of Adidas, Hugo Boss and Louis Vuitton. Thomas's roles within this project have been collating the digital assets Catherine and I have created into layered outfits. Thomas has utilised his animation expertise to create moving animations for each look that he has rendered and formatted ready for the proposed hologram output. The fifth collaborator is project manager of LJMU's Face Lab, Jessica Loom. Jessica's roles within this project have been providing the actual hologram tech and guided training on how to use the app-based technology. Jessica has also been imperative in advising the next steps in how we could scale this idea up and understanding the most effective and safe ways we can display this hologram. The initial garment design brief. I intended to create a range of garments that will ultimately culminate in 3 unique looks that are typical fast fashion product, affordable to produce for the lower end of the market. The designs and 3D assets created during this module will also be utilised to populate the mock pre-sale platform I intend to create for my final major project. So I've collated a tight colour palette that fits within the aesthetics of my MA work, so any outcomes within this project will be transferable to future areas of my research and final major project. This is a multi-product range deliberately consisting of garments with different fabric bases to showcase the visual difference this can make when designed and rendered in Clo3D. Working with Catherine, we began building our garment patterns based on the design brief. By utilising 3D garment design software Clo3D, we are able to incorporate the fitted construction of the garment in the initial stages, eliminating any possible production errors, which essentially eliminates the need to sample garments for fit purposes. This process involves mapping out all garment component measurements and digitally assembling them on a virtual avatar. No colour or fabric detailing has been incorporated at this stage. As my team are working from different areas of the world, we've stayed connected and collaborated virtually via Zoom. Myself and Catherine began developing the garment blocks into more realised designs by incorporating colour from the original brief and assigning fabric surface textures which affect the drape and look of the garment. Pictured right are the initial low-resolution designs ready for final rendering. Here are the final garment renderings. As you can see, they are significantly more lifelike than that of the conventional 2D Illustrator CAD designs that were demonstrated within the initial brief and commonly used in fast fashion design today. There is a clear visual difference in garment surface texture between outerwear and fleece styles. With more time and resources, I would have loved to have expanded on the garment offering and explored more fabrication rendering techniques. These final renders will now move to outfit building and animation stage. Working with digital animator Thomas, we began compiling key looks together for individual video files. This is a particularly specialised area of the project, as layering 3D rendered garments ready for animation has a lot of factors that need to be considered, including the layering of the garments and how they will interact with each other and move as one digital asset. My initial idea was to have the static 360 rotation animation of each outfit. However, Thomas provided expertise to further push the realism of the outfits by introducing motion walking animations which will better communicate the product's fabric qualities and functionality to the consumer. We then began the animation process. This is a time-consuming process that involves rendering multiple frames, and for a single animation this can take up to 6 hours. For the purpose of this module, we opted for a shorter 32 frame animation that can later be looped or amended in Clo 3D or After Effects. Here is an example of the rendering in motion. With the animations now created and rendered, I began researching hologram methods outside of my Semester 1 outcome that could potentially be scaled up to true to life size. I worked with Jessica Liu and utilised tech available in the LJMU Face Lab. The chosen technology was an LED hologram fan. This technology involves sharing videos or images through the associated mobile app, in which Jessica provided full training. We worked together to trial several images and videos to better understand how to get the best visual outcome. It became evident that the original asset would have to have a black background to not highlight the perimeter of the fan blades, and the hologram is most visibly impactful in low-lit areas. I identified some limitations with this specific hologram technology. To scale this up to life size with the current fans, we would have to use a minimum of 6 fans, which would massively increase cost. This would be a deterrent for cost-sensitive fast fashion businesses. Displayable areas will also be limited, as the spaces would have to have limited light. The fast-moving fan components present safety risks and hazards, so encasing the fans may be essential but could alter the view. There is considerable noise and wind created as a byproduct of the fan in motion. This could create a less pleasurable viewing experience for the consumer. The next steps. Based on the outcomes and identified limitations in this project, I've recently connected with LJMU Fab Lab technician Lawrence Baker to understand if and how we could make a large-scale version of my Semester 1 Perspex-based hologram. This would be lower in cost and reduce the issues incurred by the fan, which include excess noise, safety, and limited size. This type of hologram is created by light being projected directly onto clear perspex at a 45-degree angle. Creating this would involve the use of large screens or projectors and strategically cut and place sheets of acrylic. There are multiple options of perspex placement that would need trialling to determine the best outcome, so this may not be completed within this module. There are pros and cons to utilising this kind of hologram. The pros include the considerably lower cost price. Utilising the pyramid structure could give a 4-way 360 view of a garment. There would be no noise pollution created when the hologram is in use. This would not have to be controlled by an app. There would be more surface area to accommodate more elaborate moving animations. Some of the cons include this would take up more physical space. The hologram visual outcome may not be as effective as the LED hologram fan. The innovation uses considerably more plastic and acrylic and non-recyclable goods, which seems counterintuitive when working towards creating a more environmentally conscious business model. As these are larger scale, they will not be as easily portable. Although the digital assets created in this module will primarily be used to populate my proposed online platform, with high street stores continuing to close down, the hologram technology explored in this project could be an opportunity for retailers to continue to connect with their consumers in a personal, immersive way. The progression of this idea could be to create pop-up virtual concept spaces in which retailers could promote and market pre-sale ranges directly to the consumer without the need for physical samples and potentially filling the void of the missing in-store shopping experience.